All right, here we go. Right now, we are going to look here at our warm-up. I need you guys to write this down. Write down number 1. We need to review on what we've done before. Number 1 says, let me see if I can make this larger. There we go. Number 1 says it wants us to simplify, okay? Simplify means to combine like terms. So if I go through here, what I'm going to do is I'm going to underline my x's. And I need to put those together. So what that means is right here, if I'm going to take 3 minus 1 plus 5. When you add and put those numbers together, how many do you get? 3 minus 1 plus 5. What is that? That's 2 plus 5, so I get 7. So I have 7x. Then put together your units. -4 plus 3. That's -1. Now, this is your final answer because when it asks you to simplify, it just means to combine like terms and put together the things that are alike. So let's look at number 2. I'm going to, where we go here? I'm going to go here and erase this. Now, when you look at number 2 versus number 1, what do you see is the difference between the two things? One of them is saying to simplify, and that's when we just combine like terms. This one here says to solve. Okay. So when we're solving, what we did before was we put these, and to find our answers, into Desmos. Remember at the equal sign, I kind of draw a line to keep them separate. I'm going to put the left-hand side in first. Y equals 2 times x plus 13. Oh, nice handwriting. Not at all. All right. X plus 13. And then on the right-hand side is y equals 10. So now let's go into Desmos. Let me pull up my Desmos right here. And I'm going to put in there y equals 2 times x plus 13. 2 times x plus 13. Click below it. And then I have y equals 10, the right-hand side. Y equals 10. If you guys don't have the Desmos on up on in your computer, you guys need to do that now. I'm going to zoom out, and remember you're looking where the two lines intersect. I click right there. It tells me -8 and 10. So it tells me -8 and 10. Now remember, what you're looking for is the x number. So right here, I get my answer will be x equals -8. Now, let me give you a second. I want you to go through and try and do number 3 the same way I just did number 2. Go ahead and try that. Remember that you're putting this left-hand side, y equals 5x plus 2 minus x in the calculator, and then y equals -14. So when we go in here, click out of what you already put in, click inside. So what is it? 5x plus 2 minus x. Y equals 5x minus 2 plus x. I think that's what it was. No, 5x plus 2. I got it backwards, didn't I? 5x plus 2 minus x. Plus 2 minus x. There we go. I think I got it right this time. 5x plus 2 minus x. Yes. And then the other one is y equals -14. So I'll go down here, y equals -14. Once you put them in there, you look and see where the two lines intersect. I'm going to press right here. It says -4, -14. Oop, move my screen. So right here, -4, -14. Remember, you're looking for the x value right here. So that's your answer. X equals -4. Okay, these are the problems you guys are going to have to make sure you can get right on your test and on your STAR test. So right here on number 4, it says Jan needs to solve the equation 2x plus 4 equals 8, or equals -8. So I have this right here. If I have this equation, it's asking what is the first step? Well, I always go and remember and draw a dotted line. I'm trying to get x by itself. Here's the x. What do you need to move first? You're always doing addition and subtraction first, y'all. You have to move that +4, so you have to subtract 4 from each side. So D is what your answer would be. All right, let me scroll out of this for a second. Okay, and we're going to go into today's, oh, don't do that screen. Oop. I'm going to go into today's lesson. Moving here. All right, so this is where I need you to have out your notebook. Darn it. Okay. Move this thing over. It's being sensitive on me, y'all. And these are the notes you need to write down so that everybody should have a notebook that they are keeping all their math information in. And you're going to want to write this down. Okay, so we're going to work on what's called direct variation. Direct variation. This direct variation is a linear equation that passes through the origin. Remember that the origin is 0, 0. And it has a positive slope. It has to have a positive slope and go through the origin for something to be a direct variation. That means that as the value of x goes up and increases, like it says right here, then the value of y also has to increase. I'm trying to draw an arrow. And as the value of y decrease, or value of x decreases, so does the y. So that means that if x is going up, y is going up. If x is going down, y is also going down. Well, that's because when you multiply a positive times a positive, it gives you a positive. A negative times a negative, it gives you a positive. So that's kind of why they both have to be going in the same direction. Now, the equation for a direct variation is this right here. Y equals kx. I will tell you guys that I have this lesson being recorded. So right now, if you follow along with me, and then if you miss something in the notes, the video, I will have a link for the video for you to be able to fill them in. Y equals kx, where k is called the constant of variation. That's what that k is called, the constant of variation. Basically, it means what it's changing by. For example, if you were selling candy bars for $2 each candy bar, that K value is 2 because every time you sell it, it's $2. This equation kind of is going to remind you of slope-intercept. Which is y equals mx plus b. Okay, where b is going to be 0. It'll be 0, 0. And m is going to be your k value. Okay, so k is the same as your slope. And the y-intercept is always going to be 0, 0 when you are dealing with an equation that is direct variation. Well, let me move this up. Here are some examples that's going to show you what is this is direct is an equation that's I'm stuttering, sorry, direct variation, and this is not. Well, let's look at these for a second. We're gonna look at the knots for a minute. Look at the knots. So it says y equals 3x minus 5. If I go into the calculator, click here, y equals 3x minus 5, and I graph it. Okay, think of the two things that they talked about for direct variation. One of the first things was that the slope was positive. That means from left to right, if I start here, from left to right, is my line going up? Yes, from left to right, my line is going up. So it's got a positive slope. The slope right here is positive 3. But what was the second requirement? The second requirement was that it has a y-intercept of 0, 0. Well, look, it crosses the y-axis here at 0, 5. That's why it's not a direct variation. It has to go through 0, 0. So let's look at the second one, y equals x squared. Let me go in here, y equals x. To get the squared, remember you go down here to the bottom where it says show keypad, click here, and it's going to give you your squared. Okay, well, look at this. It goes through 0, 0, but it's supposed to be linear. Linear means a straight line. Is this a straight line? No, it's a curve. It's a parabola. It's a curved shaped thing called a parabola. It's not linear. So that's why it's not a direct variation. Now, if we look at what is an example, this one says y equals negative 3x. Oh, and you know what? I don't think that this is, because let's talk about this. They put this, where'd my thing go? There it is. Y equals negative 3x. Wait a minute. They said this was an example. It goes through 0, 0, but from left to right, this thing is doing what? It's going down. It said that it has to have a positive slope. This is negative. So let's go in here to our notes. Right here, let's scratch this off. And this is supposed to be y equals positive 3x. If I can write it nicely. So we need to change that. Y equals positive 3x. Now the second one looks kind of weird. So let's put that in the calculator and let's check it. It says, what is that? 14y equals 28x. So we'll do 14y equals 28. Well, come on, Crawford. 14y equals 28x. It graphed it for me. Now remember, here's one of them. Does it go through 0, 0? Yes, it does. From left to right, is it going up? Yes, it is. It's got a positive slope. So this one is just fine. Okay, we just had to fix this so that it had a positive slope. So on a graph, let's draw a couple examples. Oh, there it is. All right. What would be an example? It would be something like, ooh, if I can draw a line right there. Remember, it's got to go through 0, 0. And it doesn't matter what the steepness is. It's still, it's hard to draw on this computer screen a straight line. But it has to have a positive slope and go through 0, 0. A non-example would be something like this, where it still goes through 0, 0, but it's decreasing, it's going down. Another one we had was that U-shaped thing, the parabola that looked like this. So take a minute and write down that example. So let's see here. Let's look at another type that, okay. Well, come on, machine. All right. Now here's another way to figure out if something is a direct variation. One of the things that you need to see is that when we see these in test questions, they're going to say that it's either going to be proportional to, or it's going to say varies directly. When it says varies directly or is proportional to, that means that it's going to be a direct variation. So how the heck do you figure this out when you have a table? The easiest way when you have a table is you're going to go and you're going to take y divided by x. If you do y divided by x and it is the same for every one, that means that it is proportional. So right here, here's my y's and my x's. I've got 18 divided by 3. That gives me 6. The next one is 36 divided by 6. And what does that give me? 6. Do the next one. 54 divided by 9 gives me 6. As you do each one of these, when you divide the two numbers, it will always be 6. See, the equation then will be y equals 6x. Because all they're doing is taking 6 and multiplying it by x. Now, what's an example of what's not a direct variation is like this one down below. Again, y divided by x. 10 divided by 5 gives me 2. Well, if I do the next one, 11 divided by 6, does that give me 2? Well, it won't. I'm going to look it up. 11 divided by 6. It gives me 1.83 repeating. If they're not always the same, it's not going to be a direct variation. So to find the direct variations, you divide those numbers. Okay. I think I'm over here now. Sorry, I got to squeeze, look and make sure where all my papers are. Yep. All right. These are my next ones. So actually, before we go on with the next ones, I want to go back over here. I want us to practice a second. Let's look at this right here. I want you to go through right now, and I want you to try and do these. Oh, come on. I want you to try and do these two problems. I want you to try and come up with the equation if you're given a table. So let me give you a couple minutes. I want you to go through. Now remember, to figure out if it is a direct variation, you have to do y divided by x to find your constant of variation. So do that now and try and find your equations. So what happened with number 1? Number 1, again, y divided by x. 18 divided by 3 gives you 6. What about the next one? 24 divided by 4 gives you 6. 30 divided by 5 gives you 6. They're all the same. That means there is a direct variation. K is 6. So when you write your equation, it will be y equals 6x. Okay. So as you did the second one, same thing. We would have taken 4 divided by 1. 4 divided by 1 is 4. 16 divided by 4 is 4. 28 divided by 7 is 4. My K value is 4. My equation is Y equals 4X. That's what you should have gotten for these two. Okay, so let's see here. Okay. Now, these right here are saying, tell whether each illustrated direct variation. There's a little bit of argument between certain ones, but let's talk about this. In the very beginning of our notes, if I go back, I think it's up here. If I go up back to the very beginning of our notes, in the definition, it says that when X increases, right here, when X, where'd we go here? When X increases, Y has to increase. When X decreases, Y has to decrease. Okay, so given that information, let's look at these word problems and let's figure out if they would even be a direct variation. So as I move my screen up, right here, it says tell whether each illustrates a direct variation. Okay, it's talking about first, in this one, a person's arm span and his or her height. Now, I don't know if you know this, but if you take your arms and spread them out to the side and go from left to right with your arm span, and you go from fingertip to fingertip, that's actually how tall you are. Your arms are supposed to be the same distance as your height. So what this means is, as you grow and you get taller, your arm span is going to get bigger. Well, it kind of makes sense because as you get taller, as you get older, right, and you are growing, your arms, the reach that you had with your arms, they continue to grow. Well, since both of these things are going up, yes, it is a direct variation because as your height, as you get taller, your arm span gets taller. Now, on the second one, the number of eggs used in a particular recipe and the cups of flour used. So in a recipe, if it says that you're using like 2 eggs and 1 cup of flour, right? And you're making, and the recipe is one recipe for however many it is, and it tells you that you're using like 2 eggs and 1 cup of flour. If you want to double it, do you use the same amount? Like, so if you always had 2 eggs and 1 cup of flour, that's for one recipe, one batch. If you did 2 batches, what would you do to these? Would you have to use the same amount of eggs? You would go and you would double it, right? And you would make it 4 and 2. Well, every time you increase your recipe, you're still putting in that extra 2 eggs and that extra cup of flour. So this means, yes, this would be a direct variation because as you increase the amount of eggs, you increase the amount of flour. So both of these things are going up. Well, you're like, okay, well, duh, Crawford. So now what's an example of what isn't one? Well, let's look at this. If number of people sharing an apartment and how much you have to pay in rent. So to say that you have an apartment that costs $1,000 a month, and if you have one person living there, one person has to pay the $1,000, right? Well, what if 2 people live there? If you split the rent equally, how much does each person have to pay? Each person would have to pay $500. Well, if there were 3 people living there, to split that up evenly, you would take 1,000 and divide it by 3. And that means that each person would be 333.3 repeating dollars. So let's think about what's happening. the more people that live there, what happens to the amount that they have to pay, each person has to pay in rent? It goes down. Are these two things going in the same direction? No, they are not. This is not a direct variation because the more people you get, the less you will pay in rent. And remember, we talked about the fact that they have to be, the X and the Y have to be going in the same direction. All right, so now we're going to talk about these down here, but let me go up to our notes. I'll get there eventually. Okay. So right here, I gotta get to the right one. Here we go. Goodness gracious. It's saying that Julio's wages varies directly with the number of hours he works. Okay, very important when you see this varies directly. That's telling you that it's proportional. It's telling you that you're going to be able to take y divided by x. It's saying that his wages for 5 hours, he's going to make $29.75. And they want to know how much he will make for 30 hours of work. Well, to find K, remember we talked about it was y divided by x. So what we're going to do to find out how much we're going to get paid each hour, I'm going to take 29.75 and divide it by 5. Okay, so if you go and do that, I'm using just the calculator on my phone, 29.75 divided by 5, that gives you $5.95. $5.95. So that is my K value. That is my K value. When it wants you to write the equation, it'll be y equals 5.95x. That's my equation. So it says find Julio's pay for 30 hours. Well, if you want to know how much you're going to get paid for 30 hours, you would take $5.95 and multiply it by 30. What do you get when you multiply that by 30? You would get paid $178.50. Okay. Well, an example of what's not proportional is this problem down below. It says the Best Select charges $45 for a service call plus $18 an hour for on-site service. Well, here's the thing. If I talk about what happens when I use this service, if I made a table before they even come to my house, just to get to my house, how much does it say that they're going to charge me? It says they're going to charge me $45 just to show up. Then for 1 hour of work, they're going to add, you got to add on their $18. Let's see, what's 45 plus 18? So it's going to cost me $63 if they do 1 hour of work. See, my equation is y equals $18 x 18 for each hour plus 45. This is not a direct variation because of this right here. It doesn't start at 0, 0. They're charging me a one-time service call fee just to show up to the house. So in the word problems, that's what the difference is. And we'll look at those in just a little bit and practice on those. So now, if we have to come up with the equations, if it tells us that y varies directly with x, use the values to write a direct variation equation. So when they tell me y varies directly with x, this phrase, guys, right here, this is going to tell me, oh, okay, well, if it says it varies directly, then I'm going to do y divided by x. Well, y is 9, X is 3. What is 9 divided by 3? It's 3. So my equation is going to be y equals 3x. Now, here's the problems that you're going to get, and it's going to give us 3 numbers. So this right here. But the idea is it's going to tell us that y varies directly with x. So what we're going to do is set up a table. We set up a proportion, but first it's easier to set up the table and then we can figure that out. The first thing it says is when y is 28, x is 7. So when y is 28, x is 7, and I'm going to put it in my table just like this. Then it says find x when y is 52. So find x when y is 52. So if I put it in a table like this, it's going to help me because I can go over here and set up my proportion. 7 over x equals 28 over 52. Now, how do we solve this? With proportions, I'm going to cross multiply. So this right here, you're going to multiply. That's multiply. And then you're going to divide by that top number. So right now, you're going to take 52 times 7 gives you 364. So I got 364, and I'm going to divide it by 28. My answer is 13. So x equals 13. Another type of problem that we can have with direct variation is this right here where it says, Cynthia charges $4 to walk her dog. How much would she charge for walking 2.5 hours? Well, what are the things we're talking about? We're talking about how many hours she's going to walk. So x is going to be the number of hours. There we go. And y is going to be the total charge. Okay, so what is the K value? What is it that she's charging each time she walks the dog? She's charging $4. So your equation is y equals 4x. Okay, your equation is y equals 4x. They want to know how much is it going to be to walk for 2.5 hours. So I'm going to take 4 times 2.5 is easier than doing 1/2. So if I put in my calculator 4 times 2.5, it gives me 10. So she's going to earn $10. Make sure you have a minute to write that down. Let's see here. That's the end of those notes. Go over here. Let's kind of pick up right here where we left off. Right here. Just like what we were doing, I want you to take a minute and I want you to find the K value for each one of those. Because it says, let's assume that y varies directly with x. Okay. So that means that I'm going to take my equations, or not equations, my information, and do y divided by x, and that's going to give me my constant of variation, my K value. So do that now for these 3 and write down what your K values are. All right, so the first one, y divided by x. Y is 12 divided by 24. I want you to be careful because if you put the number 2, that is not correct. 12, put in your calculator, 12 divided by 24. That's going to give you 0.5, or that's the same as 1/2. So K equals, and you could put 0.5, or you could do 1/2. The second one, y divided by x. Y divided by x. Y is 7, x is 49. Well, if you put that, like when I put it in my phone calculator, 7 divided by 49. The biggest mistake is people are going to tell me it's 7. It's not 7. It ends up being 0.14285, and you can do all that. But if I reduce this, right, that's the same as saying 1/7. And it just depends on what calculators you have here at home, or if you're at school. But K equals 1/7. See, I'm not as worried about it. If this was your test question, maybe you weren't able to get the 1/7. You could go through the answer choices and take 1 divided by 7, and you would see which one would give you the same decimal. And we can kind of look at that when we have a review. So the last one that you should have done, y divided by x. Y is -36, and x is -4. That gives you 9. So you should have gotten K to equal 9. The reason why this is a whole number is because the top number is larger, right? If you look on these other ones, it's the bottom number that's larger, and that's what's giving us a fraction. All right, let me find the other ones to practice. All right, my screen went blank here. I think I froze it. All right, let's see here. Oh, here we go. All right, not very happy at the moment here. Sorry, everybody, trying to get back to the lesson. Yep, I think that's where we're at. All right, here we go. Sorry, guys, I know it's, number 8, number 9. Here we go. All right. These are the ones with the proportions. If it'll ever be friendly with me. All right. So let's do number 9 together to help you remember, and then you'll be able to do the other 3. It says, solve and assume y varies directly with x right here. And it says this hint to set up a proportion. Again, I always go in and make a table before I do it so that I make sure I don't get my numbers backwards. It's saying when y is 2, x is 6. So when y is 2, x is 6. And then it says find y when x is 24. So x is 24. And then we need to find y. So to set this up, I'm going to have 6 over 24 equals 2 over y. Now, remember what we're supposed to do. You're going to cross multiply. So the numbers that are diagonal from each other, you're going to multiply them together, and the number that's left, you're going to divide by. Okay, so let's go through with our handy dandy calculator. 24 times 2 is 48. 48 divided by 6. gives us 8. So y is going to equal 8. That will be our answer. Let me give you a couple minutes. I want you to try and do 10, 11, and 12. 10, 11, and 12. All right, let's see how you did on some of these right here. Number 10, it says when x is negative 12, y is negative 3. So find x when y is negative 6. This helps us be able to set it up. Negative 12 over x equals negative 3 over 6. Oh, negative 6, my bad. There we go. Now, what do? Multiply the numbers that are diagonal from each other, divide the one that's left. So I have, where's that calculator? Negative 12 times negative 6 gives you positive 72, and you divide it by negative 3. That gives me my answer is negative 24. So x equals negative 24. Okay. Number 11, when you went to set this up, x and y, when x is 2, y is 7. When x is 2, y is 7. Find y when x is 8. Right here. So now if I set it up, 2 over 8 equals 7 over y. Cross multiply and divide. So I get 56, 7 times 8 is 56, divided by 2 equals. So now 56 divided by 2 gives you 28. So my answer is y equals 28. Let me move my screen up just a tad. All right. So now this time, setting it up, x and y. When x is negative 3, y is 6. Find x when y is 24. Okay, well, we have negative 3 over x equals 6 over 24. Well, cross multiply. So I'm going to multiply the diagonals and divide by that other number that is not in that little bubble I just did. 24 times -3 equals -72, and I'm going to divide it by 6. Divided by 6 gives me -12. So again, they want us to find the x. So x equals -12. This is what your answer should have been. All right. Oh, don't go away. There we go. I think these are the last two. Yeah, these are the last two. All right, so let's think about what we did. Let me pull this up, the other notes. When we had this, when Cynthia charges $4 to walk a dog, how much would she charge for 2.5 hours? Remember, what they are charging each hour, that is your K value. That's your direct variation right here. Okay, and then you just multiply it by how many hours they work. So let's look down here. Oh, let me give it a minute to work. I guess I'm moving too fast. Should have just stayed with it where it was, huh? Okay. Getting closer. There we are. It really doesn't like me this morning. Hold on, let me pause. Let me be patient a second. There it is. Okay. There we go. It says Gary's wages varies directly with the time he works. Okay, it says right here that if he works 5 hours, he gets $60. This right here is going to help us find our K value. Well, if I'm going to find my K value, I have to do 60 divided by 5. So that's going to tell me how much he gets paid an hour. 60 divided by 5 gives me 12. He's getting $12 an hour. So my $12 is my K. So my equation would be y equals 12x. Well, I want to know how much he's going to make if he works 50 hours. So 12 times 50. 12 times 50. He's going to make $600. So now try and do that for number 14. Use the same thing I just did and try and do number 14. Okay, so let's think about this. First, you need to find your K value. How much does she get paid for each car? So we're going to have 120 divided by 12. What's 120 divided by 12? $10. So my equation would be y equals 10x. Then it says, how much is she going to get paid for 5 cars? Well, 10 times 5 gives me 50. She is going to make $50 for washing those 5 cars.